Okay, I'm happy to have you in our physics class. This is one of our classes in a 60-day series of maths and science revision. Now we are going to half-life. What is half-life? Okay, half-life is the time taken for half of the atoms of an element to decay. Okay, so you can say if um, the number of atoms in an element is 600. Okay, and its half-life is 3 seconds. Okay, it means that after one half-life, okay, we'll have 1 over 2 times 600 atoms decayed. I hope you understand. So while that'll be 300, we'll have 600 decayed, 300 decayed, and 300 remaining. Okay, now but we'll have to involve the formulas here because half-life you may have, okay, maybe after an element decaying for more than one half-life. So we have a conventional and we have the formula method, which we'll have to state the formulas which we can use to calculate different parameters in half-life. So the first one, which we all know, is half-life, which is T equal T over log R base 2. Okay, T here is the half-life. Okay, while the small t is the time taken for the element to decay. Okay, this is time taken to decay. This one is the disintegration ratio. I hope you're following. While capital T is the half-life. Okay, now there are other formulas that we can actually get from derived from here that will help us in calculations. Okay, now we can also see that R, which is the disintegrating ratio, okay, R is equal to 2 raised to power n. What is n? Okay, n from there is the number of half-lives. N here is the number of half-lives. Okay, so R is equal to 2 raised to power n, and this is also equal to n1 over n2. n1 is initial mass, okay, before decay, okay, while n2 is the final mass after decay, that is what is remaining. n2 is final mass or number of atoms. Okay, so we say R equal to 2 raised to power n, which is equal to n1 over n2, and take note that n on the other hand is equal to t over t. This is number of time taken for decay to occur, and this is half-life. Okay, now we have some other formulas. I'll have to rub this off, so I hope you're taking note of this. So we have some others here. So we also have number nd, that's number of atoms that decayed, which is nd. Okay, is equal to n1 minus n2. Initial mass minus final mass can actually give us the atoms that decay, number of atoms that decay. Now this is also equal to N1 into bracket R minus 1 over R. We'll go ahead to prove um, this formula. Remember that R equal to N1 over N2. I hope you remember that. R is N1 over N2. So if we use this to substitute here, okay, we can cancel out and we have N2 bracket R minus 1. Okay, that is the number of atoms that decay. Okay, if we have N1 over N2 here, this, okay, can easily cancel out and we have N2 into bracket R minus 1. Then we also go over to fractions remaining. Fraction remaining, that is FR. Okay, after decay, what fraction remain? Fraction remaining, will have it as N2 over N1. That's fraction remaining. Remember, R is equal to N1 over N2. So if fraction remaining is N2 over N1, this is equal to, also is equal to 1 over R. Okay, that is fraction remaining that is undecayed, can be 1 over R. Then we also have fraction that decayed after the half-life, the number of, okay, half-life, the word fraction decay. This one is a fraction that remain. We also have the formula for fraction that decay. Fraction that decay is equal to number of atoms that decayed. Okay, number of atoms that decayed over initial number of atoms, which is N1. Okay, remember, um, we can have this also as R minus 1 over what? R. From the previous formula we had, okay, number of atoms that decay, this, okay, this, hope you can see that. So number of atoms that decay, we can use it to get the fraction that decay. Okay, so we have N1 brackets. So this N1 cancels this N1. We'll now have R minus 1 over R. That's a fraction that decay. So we are going to be using these formulas in calculations. Okay, so in the next class, we're going to be looking at some questions under half-life. We'll also be looking at binding energy, okay, calculations under that. And yes, thank you for watching. I'll see you in the next class.